Hey, this is Ben with measureQuick,
Hi, Ben.
and this is Jim with measureQuick. And today we're just going to go over a couple of things related to heat pump commissioning, especially for cold weather, because we've had a lot of
Yeah,
questions about that. And I think it's a topic that Mr. Jim knows a lot about.
yeah, we're moving into heat pump year, and people are actually starting to install some heat pumps. Now we're breaking into, holy cow, I've never put a heat pump in before. What do I do? And what mode do I start it in? Especially like cold weather, people are starting to understand that as they're going through the heat pump, they don't have any real good expectation of what the pressure reading should be or temperature reading should be on a heat pump. And a lot of times don't know what the driving forces are for a heat pump. So it's way different than an air conditioning system. And so, yeah, there's some things we got to go cover on the probes that we require, and then on what the modes actually do, because it probably will be surprising.
Nate and a couple other people keep claiming that, oh, a heat pump is just an air conditioner with an extra part like the reversing valve. And as far as the manufacturing, it seems simple to be able to do heat pumps instead of air conditioners. But commissioning, you say, is not. There's a lot of differences that you have to be aware of.
They're not. No, that's not exactly true. When
Okay.
you commission a heat pump, you commission it exactly the same way as an air conditioner, primarily in the cooling mode. And so every single manufacturer of a heat pump out there will tell you that you have to put the heat pump in a test mode. And that test mode is typically in a cooling mode. I've never seen one in heating mode because there's some issue with the coil sizes where the outdoor coil is substantially larger than the indoor coil. So you have to set it up for cooling, and then it works well for heating. But if you're not in a position where you can actually commission it in cooling, like, so let's say it's 30 degrees outside, then it's challenging because we can't necessarily charge it by superheat or subcooling. We can weigh it in, and that's about the only way we can actually get the charge close is to weigh it in. But that only really works great if the exact set of your lines, size of your line set and the length. So a lot of times what happens is the guy gets a 50-foot roll line set, installer rolls it out, it goes down a wall cavity, it comes out the other end. It's not an easy thing to measure. It's not like you can just go in and go, oh, I have 47 feet of line set. The installer's gone. You don't know what he cut off, what they left in their truck. Oh, you're going out to service the thing and you can't get to the line set. And all of a sudden, like the weigh-in method now also doesn't become really practical. Like these methods that we have, basically we have the superheat method, which is done with a fixed orifice. We have the subcooling method, which is done with a TXV. And then we have the weigh-in method that is done if we know the amount of factory charge that went to the unit, and then also the length of the
Like,
line set that's
yeah.
attached to it, and what evaporator coils with it. Because people don't think about this too. You could have a system that you pair up with a 4-ton coil, a 5-ton coil. We gotta know by the configuration how much refrigerant the evaporator coil holds, because different coils hold different amounts of refrigerant. So line set length isn't the only variable in that thing. So if these are package units, this is really easy because a package unit comes charged from the factory. And worst case, like you have a Schrader core leak, you recover the existing refrigerant and you just weigh back in the right amount. Pretty simple. But when we have a split system, now it becomes really complicated. And then if you have a partial loss of charge and it's wintertime, like pulling the charge out is not always real practical because you can't really get all of it out because a lot of the refrigerant's emulsified in oil. It takes a lot of time. Nobody wants to work outside in the cold. Now we're at the point of, okay, I'm going to get enough gas in this thing to get it working. And how much refrigerant should I actually have? And that's where these modes with measureQuick, especially our heating mode, come into play. They are, if you go to most your manufacturers, they'll tell you to charge it by cooling, but they'll also have charts. Like Train is really good about this. I've seen a lot of their stuff over the years that tell you in the heating mode, here's what pressures that we should anticipate seeing on the system. Other manufacturers I've seen, especially the ones coming over from Asia, they don't have any information on what you should see in the heating mode. They tell you in the cooling mode, but nothing in the heating mode. And so it becomes super challenging to, especially because heat pumps, if you think an air conditioner responds slow to adjust and charge, heat pumps exponentially slower because
Hmm.
we're dealing with lower temperatures outside, lower temperatures. if we have any refrigerant in an accumulator outdoors, an accumulator is like a sort of like a space where when we hit the reversing valve, the refrigerant sort of floods in there, and it takes time for that to boil out. If you're not working diligently on a heat pump and you try and rush it, you're going to be back out again for sure, because an hour later it's going to be tripping on the high pressure switch. You have to give things time to adjust. Let's talk about what we can do in the heating mode with a heat pump. First of all, you are going to require like a heat pump. Yeah, let's talk about the two interconnecting lines, because it's important for mapping. On an air conditioner, we have a liquid line and a suction line, right? And because they only have one function, the liquid line feeds liquid to the TXV and the indoor TXV, and then you have a vapor line that's taking the vapor back to the condensing unit outdoors. On a heat pump, we actually have a whole different name for the line. It's called, it's no longer called a suction line. It's called a vapor line. And I might have just misspoke a second ago, but I think I did. But the suction line is dedicated for suction back to the compressor. Vapor line means it can be vapor traveling either direction. So it can be cool suction gas coming back from the evaporator in a cooling mode, or it's hot discharge gas leaving the reversing valve and going into the indoor unit. So because on a heat pump, we have an indoor coil and an outdoor coil. And because what the functions of those coils actually change. So the outdoor coil can become the evaporator and the indoor coil become the condenser in the case of a heating mode. And in the case of cooling mode, it goes just like we normally have outdoor condenser and indoor evaporator. So now we've changed terms. So on a heat pump, we have an indoor and outdoor coil. On an air conditioner, we have a dedicated condenser and a dedicated evaporator. On an air conditioner, we have a dedicated suction line and a dedicated liquid line. On a heat pump, those things change. Indoor coil, it can serve two functions. Outdoor coil can serve two functions. Now we have a vapor line because it can be hot vapor or cold vapor. And we have a liquid line, and the liquid can travel either direction, because it's either traveling into the indoor metering device and cooling or into the outdoor metering device and heating. So now we have two metering devices too. We have one indoors and one outdoors. And so now we have to make sure that we have proper evaporator superheat in the cooling mode, and we have proper superheat entering the compressor in the heating mode, because we don't want to flood our compressor with liquid. So we have two valves that may need adjustment, need testing. And so that means that we have to, again, like there's a true suction line on a heat pump. So the true suction line is, if you look at the middle port of your reversing valves, the middle port is always the true suction. It goes right into the accumulator or into the compressor, depending on if you have an accumulator or not. And then the bottom port, if you think about, there's like a three top ports. So the center one here is the suction line. And then there's a bottom port comes off, and that's always the discharge line. Always. On every reversing valve, it's always the same. Whether these two ports can swap, so this could direct hot gas on either one, depends on how the manufacturer set it up. If you ever replace a reversing valve, you put it in backwards, you'll change the whole configuration of the heat pump, because it'll flow the gas in the wrong direction. So it's really important to understand how your reversing valve works. But regardless, now in the heating mode, in measureQuick, we have to do some remapping, and then we do some different probe placement. First of all, we're going to remap, and we're going to call, we need to have a separate probe. Typically what we use for our discharge line, we'll remap to our vapor line. And that vapor line is going to be hot vapor that's going into the indoor coil. And then our suction line clamp will actually go on the true suction line. And sometimes it's hard to get to. So you either got to take a panel off the heat pump, or you got to take the condenser fan loose and reach down inside and put that probe inside the outdoor unit itself. And I usually position that switch in case that unit shuts off, so I can reach in with a little rod or something and press the button on the switch and turn it back on again, so I don't have to take it back out of the unit. So now we got a suction line or a true suction. We've got a vapor line, that is the interconnecting line between the indoor and outdoor unit. We still have a liquid line. Outdoor air temperature, we need to get outdoors. That is like the most important probe on a heat pump. That's the driver for everything. We're going to put that outdoor air probe. It needs to be about midway on the coil, out of line into the sun. We don't want the sun shining on it, because we want to get a true outdoor air temperature. What's the outdoor air temperature entering that heat pump? Because that's going to really determine how much heat we have to work with. And then we're going to measure indoors. We're going to measure total external static pressure, and we're going to measure supply air temperature, return air temperature, just like we would on an air conditioning system. Now, when you put a heat pump in the heating mode, it takes time for the heat pump to get up to its optimal operating conditions. If it goes through a defrost cycle or anything like that, it's going to take a solid 15 to 30 minutes for it to fully recover. So you need about 25 to 30 minutes of runtime in the heating mode before you can really start to analyze the charge, right? And on measureQuick, what we're doing is we're looking at a couple of different things. We're giving you approximate pressure targets that we would expect to see on a heat pump at full load operation. So this, again, if you're talking a variable speed piece of equipment, turn the thermostat down at least 10 degrees below above the indoor air temperature setting because we're in heating. We got to turn this thing up. We got to let that inverter get fully ramped up to high speed because we really can't evaluate the system at part load. So we're going to run the inverter fully up, let the system stabilize, make sure the charge is stable, and then we're going to be able to start to quantify how this system is actually performing. The key thing here is that it needs to be stable and we need to give this thing time. At the same time, what we're doing is on the superheat side of this, we're making sure that the system is not flooding. In other words, we don't want refrigerant liquid turning back into the accumulator or back into the compressor. What we're trying to do is keep that compressor from having too much saturated liquid because that lowers the discharge temperature of the heat pump. We want to get maximum discharge temperature out of it. Now, the other thing is that any charge with the correct charge in a heat pump is going to compromise its operation. Obviously, if we don't have enough refrigerant, what's going to happen is we're not going to transfer the right amount of heat energy. But if we have too much refrigerant, what's going to happen is we're going to stack it in the indoor coil. And so this is just like overcharging an air conditioning system. The whole magic behind making a heat pump actually work is turning the refrigerant vapor back to a liquid. It's that change of state of refrigerant where all the heat comes from. It's not the hot discharge temperature. A lot of guys think, oh, I need to get the discharge temperature up higher. That's sensible heat energy. That's the heat. There's very little BTUs come from desuperheating the refrigerant. Where all the magic happens is when we turn the refrigerant from a vapor back to a liquid. In the indoor coil, we want to maximize the amount of space that we're using to turn that refrigerant vapor back to a liquid. If we start overfilling the heat pump, then we stack the liquid. The outdoor metering device starts clamping down, and the liquid stacks up inside the indoor coil, and we reduce the amount of space available for condensing. So we end up with what looks like a higher head pressure, which you might think is better, but it's actually just the opposite because now we have this high temperature but very tiny coil, and it doesn't work as well as a heat pump would if we had that fully active coil. So it's a little bit of a challenge.
Yeah, it seems like there's a lot of technicalities here that, like, if you try to do it in heating mode, it's like, unless you're being very careful, the probability of you doing it wrong is very high.
Well, that's the whole thing. So, I mean, some of what we're trying to watch for is what I watch for when I add refrigerant on a heat pump is I add refrigerant, is my BTUs going up, right? Is my output going up? Is my EER going up? Because if I add a little refrigerant in and I see an increase in capacity, then I'm going the right direction. Add a little more gas and increase capacity. Eventually it's going to plateau. We're adding more refrigerant in, it's going to go down in capacity because now I've crossed that point of turning refrigerant, maximizing that indoor coil space, and now I'm stacking it in there, basically making it into a liquid line. This is where I can watch my subcooling, right? So on a heat pump, again, we're still watching subcooling, but now it's the subcooling coming out of the indoor coil instead of out of the outdoor condenser on the air conditioning system. So I'm watching a lot of things happening at once. And so I might start off with no subcooling, which means I got no liquid coming out of my coil. As I'm adding gas, I start to see the subcooling increasing, and I see my BTUs increasing, and I see my amp draw going up. When I see my amp draw go up on my heat pump and I see no increase in output, then I know I've peaked out on how much refrigerant's in that thing. And so we're trying to catch it before we hit that peak point, because once we cross the peak, then we're going downhill, right? Ideally, what we do is we get enough refrigerant in that we get enough capacity. So this goes back to, okay, now what do I got to do next? All heat pumps are pretty much bound by physics. So when we put the SEER rating of the heat pump in, we're going to get a certain number of BTUs out. So let's say it's a 60,000 BTU unit. At 0 degrees, it might only be a 52,000 BTU unit, right? And at 70 degrees, it might be a 68,000 BTU output unit. And so what we really need is for the manufacturers in extended performance tables is so we can go in and say, okay, at what temperature, how much capacity am I expecting to see at this at this outdoor air temperature? So that becomes my target. Is what I'm trying to do is maximize the amount of capacity the heat pump's outputting. And when I get the charge exactly correct, I'm going to have the right amount of refrigerant in the indoor coil, right amount in the outdoor coil, maximizing my indoor coil's efficiency, and I'm going to get the maximum heat output at the minimal amount of amp draw for that heat output. This is where we're looking at some of the manufacturer's data and this is actually a tuning process because
Mhm.
we don't have targets like we do with air conditioning where I can say, okay, charge it to 9 degrees of subcooling. So this is why ideally we always commission an air conditioner in the summertime, and we
Mhm.
always commission it when the conditions are favorable, because if you try and condition it in the wintertime, it's much more challenging. And this is also why if I'm commissioning a heat pump, I'm always writing down the total amount of refrigerant on there. Some poor soul has to come back in the wintertime. They can just remove the gas and weigh the gas back in if they think there's a charge issue. And so think about your fellow technician that's going to go out there, 2 or 3 years from now and wonder what's going on. Now, there's a couple other things too that are tricky that we're going to run across is your outdoor coil now becomes the coil that's absorbing the heat in the wintertime. If that coil's not clean, like it's full of cottonwood or leaves or just general dirt and debris, it's not going to perform the way that it should. Obviously, our suction pressure is going to be lower than normal because the coil's not absorbing the amount of heat that it should absorb. And so now if it's the middle of winter, it's 0 degrees outside, how are you going to clean that coil? You're going to get water out. You're going to water rinse it. But like these things are challenges. So again, maintenance
Just douse
becomes,
antifreeze on it, right? Like that should
yeah,
be
douse
fine.
it with, RV antifreeze. Perfect. Yeah. But no, it really becomes a challenge to serve as a heat pump in the winter. So we want to make sure that we're doing this stuff in the fall. You do it in the fall or your summer before the winter comes around. Otherwise, wintertime service is not easy.
And
So
wintertime
the
install also not easy.
yeah, the only time thing with an install that's a little bit better is at least the coils are clean. At least that's a variable. But so the whole idea behind heating mode measureQuick is it's a sanity check and it's a tool. It shows you the right ranges you should be in, or typical ranges you would be in for a heat pump of that SEER at these given outdoor air conditions and these return air conditions. It's giving you some target ranges. If you have no idea, it's the first time you ever started a heat pump in the heating mode, and you go, oh my God, what should the readings be? That's what we're trying to tell you what they should be. And we're telling you if anything's way out of range, that would be much further out of range than we would anticipate it being out of range. And then it gives you a tool to measure your output of your heat pump, which is a really good indicator of how well that heat pump's performing. And we can measure the airflow with a true flow grid, or we can do estimated airflow and measureQuick. We can do it two different ways, but it'll give you an idea of how much heat output your heat pump's outputting. And that'll really tell you how well it's performing. And that's where we also have a non-invasive mode, which is what we usually recommend you do if you're in a heat pump in the heating mode is just look at your outdoor air temperature, look at your heat output. If your heat output falls in line with what the outdoor air temperature expectation is, again, now this is all at full load. So we got the heat pump operating at full capacity. We're not some part modulating place. We're at full capacity heat pump. The measureQuick will tell you, okay, this anticipated airflow and this outdoor air temperature, this is how many BTUs you should be outputting. And we can measure electrical. We can get approximate COP or coefficient of performance.
Mhm.
But it's a testing and a tuning tool. It's a sanity check. But we are bound by physics. So if the manufacturers could do this better and provide us with more information, they would do it. But they can't because they have all the same limitations. We have to make sure that we're putting this heat pump in the cooling mode to get the charge dialed in if we're going to use the superheat or subcooling method. And that's the only way to do it. We are very quickly in measureQuick, we're going to be adding in the field piece charging blanket, which is another way you can charge in the cooling mode down to about 37 degrees Fahrenheit. We'll be able to widen out the amount of the being able to run a heat pump in the cooling mode. But one word of caution, also, if you're starting a heat pump in the winter, is you need to have it plugged in for about 24 hours before you turn it on, because you need to give the crankcase heater time to warm up the compressor oil. Otherwise, when it starts, the refrigerant and oil are emulsified together and are mixed together, and the refrigerant will boil and it'll carry all the oil out of the system and into the indoor coil. And it takes forever to get the oil back from through the metering device and get it operating normal again. And it could damage the compressor without having sufficient oil for lubrication in there. The manufacturers will tell you before you start it, make sure that you have that crankcase heater on. A lot of times what I'll do is set the heat pump in place, electrically wire it first. If we're doing it in the wintertime, wire it in, put the disconnect in, let the heat pump just start naturally warming up. And then I'll do my piping, and I'll do my controls and all my control voltage and all those other things. You just have to disconnect power when you're hooking up your control voltage back up to it. But the idea is if you're doing it in the winter, first thing is get that crankcase heater going so that you can push the refrigerant out of the compressor and into the condenser, because it's going to just migrate to the coldest place of the system, which is typically, compressor is going to be one of the colder places at that point. Yeah, so it's not easy, it's not impossible, but it's a whole different set of variables that really complicate things. And again, measureQuick was just built to give you that sanity check so you can have some confidence when you're working on a heat pump in the wintertime and some expectations of what those readings should be.
But it won't be a full commissioning. It's something where, due to the limitations of physics, just summing it up, the manufacturers can't actually provide the adequate information to help a professional, whether they're using measureQuick or not, to be able to commission the system. It's just not possible in heating mode.
Yeah, it's just because the refrigerant, the coil sizes, it's basically where a portion of the refrigerant's not in the evaporator coil when it's in the heating mode or in the condenser. So we've changed the coils around their operation. And so we have to temporarily store that refrigerant somewhere. It's either an accumulator or it's in a receiver, but it's not in the coils. And so there's no way of accurately charging it in that heating mode because the refrigerant's not all where it will be when it's in the cooling mode. And the most important thing is if you add any refrigerant to a heat pump in the wintertime is go slow, because depending on there's what's called a true suction port on a heat pump. Again, this is why we have the vapor line and liquid line. The vapor line is going to be hot vapor going out. And so it's going to have very similar pressure to the liquid line. So you can't add refrigerant to the vapor line on a heat pump. You've got to add it into the true suction. Depending on if they pipe the true suction port to before or after the accumulator, if you dump the refrigerant as liquid right into the accumulator, there's no heat energy to boil that refrigerant out. So it's going to come out of there really slow. And then it's a vicious cycle because as the refrigerant boils away, it even drops further in temperature. So that refrigerant just does not want to come out of the accumulator. So you might look at it and go, oh, my charge is fine. And 30 minutes later, you're overcharged. And you're going, why am I coming back here? What's going on? And you added in two pounds of refrigerant too much. And it all was just sitting in the accumulator, just going, I'm not doing anything until you leave. And
just warming up.
Yep. So this is again where we have trending in measureQuick. And so what I usually watch is my trends. I'll watch my high pressure. Is my high pressure stable? Is it slowly creeping up? If your high pressure is still slowly creeping up, then don't leave till it's stable, because you don't know where that charge is going to end up until that has stabled out. So trending is a very powerful tool in the heating mode to make sure that things are stable before you leave. But yeah, so think of heat pump heating mode as a tool to help you do what otherwise would be the impossible in the heating mode. And this is like exponentially better than what we have today, which is just a very wide set of guidelines for the manufacturer. And when we're talking about heat pumps and we're really sizing for the duct system, sizing for the load, we don't have a lot of extra energy to compromise the operation. So like we have a 100,000 BTU furnace and we're oversized and it only outputs 80,000 BTUs on a 60,000 BTU load. Who cares? Not a big deal. Yeah, it's inefficient, but we're still going to heat the home. But if we have that same thing, we have a 60,000 BTU heat pump and we have a 60,000 BTU load, and all of a sudden we lose 10% of our cooling efficiency, our heating efficiency, we're going to start losing ground in the home. And it becomes, as we're more closely sizing equipment, proper operation becomes really much more important.
Yeah, and going slow. Like it's
Mhm.
once you properly size the equipment, and then if you're trying to do, not startup, but if you're servicing or doing any of the steps to get the system online during the cold season, it is a slow process. And at least you guys have thought of all of the little bits and pieces in measureQuick to make it easy for someone. But yeah, that's challenging. One
Yep.
one
So,
last. Oh, go ahead.
and we do have some diagnostics and things in there that help you with the diagnostic side. But the key things are to remember is you got to map the probes right. So we got to make sure we map the discharge line to the vapor line. And we've got to make sure that we put the true suction line on the suction line clamp on the true suction, which is inside the condensing unit. It's the one between the reversing valve and the compressor. And because we're measuring outdoor superheat now at that point, not evaporator superheat. And then we got to make sure that we use an outdoor probe. Really important that we get a real good sampling of the outdoor air, and that probe's placed mid coil out of line of sight of the sun. Then we got to put it in that test motor, put it in, get it all the way ramped up, get the inverter all the way ramped up, or if it's a single stage heat pump, just get it in high stage and then let it run for about 20 to 30 minutes before we start to make a charge evaluation, because it takes time. And
Mhm.
if you're, again, you gotta, this is one process you can't rush, because I can guarantee you, you will be back 30 minutes later if you don't wait to 30 minutes. All you're going to do at that point is waste gas, generate a callback, and tick off your boss and tick off your customer and create all kinds of problems that you could have avoided had you just waited an extra few minutes to make sure before you ran away that it's running right. And then the other important thing, remember, if you're working on a heat pump, use a biflow dryer. If you see a dryer that doesn't have an arrow pointing both directions, somebody put the wrong dryer on the heat pump. And you need to make sure that you get that out of there right away, because putting refrigerant through a single flow dryer in reverse a lot of times will disintegrate the dryer and it will end up in the system. Make sure you don't let that
Neat.
happen, because I've done that personally.
Oops.
So worked great in cooling mode though. Made it through the whole season.
One season.
Yeah, one
Oh,
season.
awesome. And ductless mini splits. Is it the same challenges? Just and
It's a lot of the same
measure quick can be
challenges,
used
except
too, or
yeah, we have a mini split mode for mini splits. It's the same set of challenges with less information, because mini split manufacturers have fewer ports. So now we only have we basically have a vapor line in this case only. So we have a hot gas going out and we have warm liquid coming back when it's in the heating mode versus cool gas out and back. So things change around a little bit. But the best metric of performance, again, is going to be BTU output at outdoor temperature, because information on mini splits. And then there's even more challenges, because you don't know what it was rated at. Was it rated at, because they have hyperheat modes where they're overrunning the compressor. Was it rated at that output in hyperheat, or was it rated at the output in standard heat? And what temperature was it rated at? And
they don't
it's
say.
like, they don't say. Yeah. So there's the best thing to do with a mini split is always carefully measure the line set before installation and then weigh the charge in, because there's just not a good way to charge in these things in the heating mode at all. You can't do it. They
Hmm.
got to be in the cooling mode, because there's no way to run it in heating. There's no true suction port to measure suction on, because you only have one port typically. And so it's a whole new set of nightmares when you talk about a classic mini split.
Oof.
So do it once, do it right, do it in the summer or in the shoulder season. If you're in the winter and you have to do it, use measureQuick as a tool to get the charge in range, and then plan on a return trip, because you're going to need to do it.
All right. Great new technology, but that comes with a lot of challenges. Awesome.
Oh, yeah.
Well, thanks, Jim. And
All right.
hopefully that was able to help anybody out there who is going to be servicing or installing heat pumps in the heating season, which is now. Good luck, everyone. And yeah, this has been
Any
Jim.
questions or comments, leave them below. We'll try and answer them.